Hello and welcome. Last time, you were called on by the Kittitas Valley Math Circle Agency to become a trainee on encryption. Your performance went so well that today we need your help once more in cracking codes. We will be training you on how to become a junior level code cracker. When we learned about encryption last, we learned some first steps towards encryption and the different ways we can encrypt things. Do you remember some of those? We covered the Wiles cipher and the grid table method. If you haven't seen them or you don't remember, you can go ahead and check out our KVMC YouTube channel and check them out. Since then, we have updated some of our methods to be slightly more complicated. This ensures that those outside of our KVMC agency will have an even harder time cracking our codes. Before we start, you will need paper, a pencil, and a copy of the Playfair cipher that we will be using today. This can be found in the comments below this video. So, what is our new method? It's called the Playfair cipher. Let's work through it together. This is a copy of our Playfair cipher. This is what we will be using to encrypt and decrypt our messages. This is a 5 by 5 grid. Now, what is 5 times 5? 25. That means that there are 25 total boxes in the entire grid. This means that since we have 26 letters, we will need to choose one letter to leave out. In this grid, we have chosen to leave out J. So, moving forward, we can start figuring out how to encrypt our messages. Over here, I will be writing a message and trying to encrypt it. Let's start with the word Playfair. Now, the first thing that we need to do when we're going to encrypt a message is separate this word into letter pairs. That means I will separate each pair by one space. This will look like this. Great. If there are two letters of the same type directly next to each other, we will need to place an X between them. Here, we don't need to worry about that. In future examples, we might. After doing this process of separating our letters into pairs, if we end up with an odd number, we can also add an X to the end to make sure that we always have an even number of letters or complete pairs. Now that our message is ready to be translated, we will look at this table to discuss our 3 rules for encryption. Something to note that we covered last time is that these are columns and these are rows. If our 2 letters in one pair are in the same column, we will translate them as the letters directly below each letter. For example, if our pair was EU, then our pair would translate to KZ. If one of those letters is on the bottom, in this bottom row, we will take the letter immediately on the top of that same column. For example, if our letters were I, Y, then moving down one, we would have O, and Y would go up over to D, ending from I, Y to O, D. If our two letters in one pair are in the same row, translate the letters directly to the right of each letter. In the same way, if the letter is on the rightmost column, when we try to move to the right, we will come all the way back around and start on the left and take this letter. For example, if we were using the letters G, K, this would go to H, F. Again, G would go to H and K would go to F. If our two letters are not in the same row or column, we can create a rectangle out of them and choose a letter that is horizontally opposite. For example, let's say our letters are R and H. We can make this rectangle out of these letters and take the letter that is horizontally opposite to each. When I think of the word horizontal, I think of horizon, kind of like seeing the sun on the horizon. So I would take H to G going this way, and I would take R to S going this way. Therefore, if my letters were R, H, it would go to S, G. Now that we have this in mind, let's go ahead and encrypt this message. Let's start with PL. Coming over to my cipher, P and L are in the same row. That means I will take my letters and translate them each to the right. Therefore, P, remember, wraps all the way around and goes to L. So I can put an L. And L, moving to the right, becomes an M. Moving on to A, Y. Y. It looks like we're going to need another rectangle. Now we can draw our rectangle from A all the way to Y. With this in mind, we now can take the letter that is horizontally opposite to these. This means that A goes all the way over in our rectangle to D. So I can put a D. And our Y will go all the way over to a V. And I can put a V. We can now move on to translating FA. FA are in the same column. Therefore, each will get translated to the letter directly below it. F goes to L. And A goes to F. Finally, we can move on to translating IR. IR are not in the same row or column. So once again, we will be creating a rectangle. This time, I'm not going to draw the box, but instead I will challenge you to try to see which letters they would translate to without it. Go ahead and pause the video and take a moment to test it out. So, with this rectangle in mind, I would see that I goes to G. and R goes to T. This is our final encrypted message. Good job! Let's go ahead and do another and test out our skills. Let's try to encrypt the word January. Now, remember, we left out a J in this entire table. That means that we need to substitute another letter for it. For this reason, we will be substituting all J's with the letter I. That means that January goes to this before we even start anything else. We can now break it up into our pairs. This becomes IA, NU, AR, and Y. Now remember, if one of our pairs is incomplete, in other words, we have an odd number of letters, we need to complete the last pair by putting an X. So we can now begin encrypting our message. We start with IA in a rectangle format, A and I not being in the same column or row. Therefore, A goes to D and I goes to F. IA goes to F, D. And U, if I find N and U, we are going to be using this rectangle method again. Therefore, N goes to P and U goes to S. Next, we complete AR. AR, not in the same column or row, means another rectangle. A in our rectangle goes to B. R in our rectangle goes to Q. And finally, YX. YX. Since they are in the same row, we can use the letter that is directly to the right of each letter. So, Y goes to Z, and X goes to Y. And this is our final encrypted message for the word January. In the next video, we will discuss how to decrypt these messages. Until then, some things to think about. How could you make this process more complicated? For example, I might consider making my own table with rearranged letters that are not in order. How much different would this process be if we decided to leave out a different letter that wasn't the letter J? And how could you figure out how to decrypt these messages without hearing the directions for it? I might consider thinking about how we encrypted these messages and possibly work backwards. Go ahead and give it a try before you watch the next video. The great thing about these crypto skills is that I can use them to talk to my friends while maintaining quarantine as well, and I don't have to worry about someone intercepting my message. Here you go. Thank you for joining us for the first part of your KVMC Agency Junior Agent Training. Until next time.